Now you can see that I've already started my graph here. The process for making our velocity time graph is going to be very similar to the process for making the displacement graph. So I've already marked my time axis, that's my x-axis, and I need to mark my y-axis. That's where we're going to put velocity. And just like we did for displacement, I'm going to go back to my data charts. I'm going to look at the highest velocity for each data set, and I'm going to find the very highest of them all, which is 112.7. Then I'm going to count the lines on my graph. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. And I'm going to take my calculator, 112.7 divided by 26. Remember, your numbers will be different from mine. And that gives me 4.3346, blah, blah, blah. I need to round that up to a number that's easy to count by. In this case, that makes it nice and round 5. So every line is worth 5. And I'm going to number all the way up to the top. Remember to also label your y-axis, and that's velocity in centimeters per second. Once you have your axes labeled, then you can go ahead and start plotting your velocity points. Just like we did with the displacement graph, you're going to use the same 3 colors to represent your same 3 buses. Remember, mine are pink, purple, and green. Yours will be whatever you used yesterday. But you should use the same color to represent the same bus. That way all of your data matches. Go ahead and pause this video while you get your graph set up. Hit play when you're ready to see what to do next. All right, so now you can see I've completed my X and Y axes and I've plotted my 3 colors of dots. Now we're going to connect the dots just like we did on the displacement graph. And you can see that this is making a pretty straight line. It's not perfect, and there's a lot of reasons why it wouldn't be perfect. That could be where I've chosen to plot my points more than anything else. Maybe I just didn't put my dot high enough or low enough. But I'm going to trace over this and I'm going to make it a little bit more solid, a little bit thicker line. And you might notice that I'm not starting at 0, 0. And there's a reason for that. And I will show you that reason right now. So this is our spark tape for the small bus. This is the one that I marked and measured to get the information that you have in your data chart. And if you look real closely, you can see there's actually some marks before where I started measuring. And those are hard to read. You can see that they're all jumbled up. And so we didn't actually start measuring and counting until after the bus had started moving, which means that at our 0 second point, the bus wasn't moving at 0 centimeters per second. It was actually already moving. So we didn't start at 0. We don't know what that velocity was because we didn't calculate that part. So we're just concerned with the rest of it. Now that we have the lines on our graph, what do we do next? Well, you notice that our velocity graph is now showing a sloped line. The velocity graphs we've done before have been all horizontal lines. They've all been straight across. So this means something different, changing velocity. And in this case, that is our acceleration. So we can use the slope of a velocity time graph to find acceleration. Now we're going to actually calculate the acceleration for each of these three lines. And we're going to assume that the reason why our lines are not perfectly straight is due to human error and not due to mechanical error in the bus. We're going to assume that the bus had a constant acceleration throughout the trip. So in order to find the slope of each line, we're going to take the last point and the first point. So go back to your data chart, and again, your numbers will be different from mine. I'm just showing you the process. And I want you to write the coordinates of your first point and your last point. Write them right on the graph. So for me, it's 0.1 and 12.0. And my last point is 2.1, 112.7. Now we're going to find the slope. Remember that slope is rise over run. y2 minus y1 over x2 minus x1. Or in other words, our change in velocity, our delta v. Final minus initial. Where did you end at minus where did you start at? So let's write that down. 112.7, and we have units, centimeters per second, minus 12.0 centimeters per second, divided by our last time point, 2.1 seconds, minus our first time point, 0.1 seconds. So when I put that in the calculator, 112.7 minus 12.0, 100.7 centimeters per second over 2.1 minus 0.1, 2 seconds. Some of you guys have been leaving your numbers like this. This is not an appropriate answer for a physics class. You need to continue with the math and give your answer in decimal form, please. So 100.7 divided by 2 gives me 50 point, and we're going to round in this case to the tenths place. We're just going to give a general place value, 50.4. But now what are our units? Centimeters per second per second. These seconds don't cancel out. They're both technically on the bottom of the fraction. So we're not left with centimeters. We're not left with centimeters per second. We're left with something new. In this case, centimeters per second per second. You can also write that as centimeters per second squared. So here is our acceleration, or here's my acceleration for this line. Go on and calculate your acceleration for all three of your buses.